So now what we'd like to do is go through 6 cases in which machine learning has inadvertently gone wrong, much to fanfare and probably negative acclaim. So what can we learn from these lessons? Let's take a look. Our first case example comes from Microsoft, and it comes from actually my domain of expertise in natural language processing. Natural language processing scientists in Microsoft were very interested in taking advantage of deep learning methodologies, such as the ones that we covered earlier in week 9, and to put them to good use in generating language. And as you know, one of the big problems in deep learning is to secure data. So what better way than to have a chatbot interact with people, agents on the outside, and learn from their conversations how to create even better language. And the result was a robot called Tay AI, which they debuted with much fanfare, but had to shut down within 24 hours. So actually what happened was quite a lot of internet participants fed it quite negative data, racist data, sexist data, and then the bot learned how to emulate that from the online training machine that it had. Now let's stop for a second and think that Microsoft actually didn't have a very bad idea about that. In fact, they had actually piloted this Tay AI idea in China with another agent very similar to Tay AI called Xiao Ice. And that agent interacted with millions of Chinese online participants without ever getting this type of negative bias. And it had to do more probably with the cultural aspects of how Chinese internet users interacted with the system compared to ones in the Western culture. So people who encountered Tay AI at the very beginning, when it went online, were already interested in poking at it and seeing how it would react. So they started to feed it adversarial data in some ways and trying to get it to perform its tasks miserably, and they succeeded, right? Probably those of you who've read tweets or news reports from this era found out that within 24 hours, Microsoft had to take down the robot because even to innocuous prompts, it was giving racist and sexist comments. So the lesson to be learned here is that when we're gathering data from the outside, we have to be careful about where we're gathering it from and probably do much work on sanity checking the data before we feed it into a machine learning system to operate on. And while we might think Microsoft is one area, there are many tech giants responsible for problematic things, okay? Let's turn our attention now to academic institutions. So there have been academics who've also taken the machine learning paradigm and probably put it to uses far beyond what we would consider ethically responsible for. So this is a current thing that's going on much in China, where our Chinese partners are using machine learning to help to identify criminals, but depending on the slant and spin of an article, you might find this written a little differently. So in this case, here we're trying to use face recognition using some of the techniques like VGGNet or UNet, etc., and trying to identify facial features that would identify a criminal. And let's stop to think about that for a second. Does that actually make sense? Do you want to discriminate people just based on your appearance, like judging a book by its cover? Well, if we believe that there is no actual inherent bias to or for or against a particular facial feature, then basically what we're trying to do is pick out noise. Okay, so as you can see here, the Western media, especially through MIT and other places, said that basically this particular scientific endeavor was probably a little bit misguided here, right? So the idea is to identify facial features that might correspond or correlate with a criminal behavior. And if we don't believe this is true a priori, then basically this type of technology would be picking up a signal where there's none and then giving some unfortunate results to predicting whether somebody is a criminal or not. Okay? And related to this, this was another group that was in the Western media, also from the U.S., not from China in this case, which was using machine learning for almost the same idea, is to pick out facial features to help guess whether you're gay or not. And you can imagine this caused a lot of fanfare because many people, especially in this day and age, are still very sensitive about their sexual orientation and may not want that disclosed by an algorithm. So this was a part that we have to be very careful at making sure we don't disturb things that are supposed to be private by taking private data and trying to manufacture classifiers to guess that. Another case is using machine learning to do data analytics. Okay, here is a case of Target, a very large US retailer, using data analytics on previous consumption, that is shopping history through a credit card, and offering promotions. And you can see that this might be even more prevalent in the future as you're driving or walking around in an environment, and the environment itself is a machine learning recommendation system. It might suggest products for you to consume. And certain products are more sensitive than others. It's probably not such a bad thing if they suggest what type of restaurant to go to, but it might be very inappropriate to suggest like an abortion clinic or going to a divorce lawyer or something like that if the parties that you're with may not have the same type of information uh, available to them. So this is a very interesting case because basically uh, there was a parent in the U.S. who was shopping and then was offered a offer to get a pregnancy abortion pill or pregnancy test. And this was done through the machine learning and data mining algorithm and then passed on to a recommendation engine. And of course, the parent is asking themselves, why am I offered this type of promotion, to take on, to get a pregnancy test? And, they took this to the Target department, their marketing department or somewhere in the executive chain, and they found out that it was actually because their teenage daughter was using products or consumed products that was related to pregnancy. And so the uh, father found out about this before he was informed by her daughter, which of course is not a good thing. So they were in quite a lot of hot water for doing this machine learning and mining. And this means, even though we have the capability technically of learning and divining, let's say predicting certain classes of information, we may not want to do so. To iterate this point, we see this a lot from our social media feeds too, being a place where inadvertent machine mining can cause problems. So here's a case in The Sun, a tabloid in the UK, that is illustrating this point, where people who post information about their vacation on social media previously around this time period, this was quite a while before, in I think 2015 or so, might not have thought about the privacy constraints of their posts. So when they made their posts public, there were unsavvy individuals who tried to mine public Facebook feeds or other social media and divine whether or not somebody is actually at their home address. Okay, so it's a not too far away conclusion is if you can guess that they're not at home, to use social media to mine where they're located, and then these unscrupulous individuals can go rob the estate. Okay, so this is an important problem that we have to be aware of when we're using machine learning algorithms to learn things, but also from the human-computer interaction point of view. Even though algorithms can do this, we can also inform potential users of social media. Hey, maybe you should think twice about posting this status because people who are looking at your posts might actually know that you're not home. Okay, so this illustrates the dual side of social media, being able to keep up with the Joneses, as they say here, to show off, where you're going and that you're having a great time, but balancing that with privacy and ethical constraints that we would need to think about when we're applying machine learning. While we're on the topic of social media, let's talk about the platform leverage that they can produce. So here's a case where Facebook, a couple years ago, in 2011 or so, actually executed a secret experiment, which they didn't tell anyone about, and they got into a lot of trouble for this. So what did they do actually? Well, what they did was they actually put different algorithms to practice on creating the social feeds for users. So they said, we want to figure out whether our algorithms have an effect on how people feel about themselves. There's sort of a good-natured hypothesis, but what they did to go about it was incorrect. What they did was they exposed certain users in their experimental group to more negative posts that were more polarizing, more hating, and other things like that. And surprise, surprise, not surprisingly, they found that it affected their sentiment. They were more depressed, more prone to circulate more hateful and negative posts, and they declared this a success. They published this in an academic journal, and as soon as they did this, they got a lot of flack, right? Because they didn't tell their users that they were being subjected to this type of test and that they were actually guinea pigs, okay? So you have to think about this for a second. In fact, almost all of our tech usage today is predicated on particular platforms running algorithms, and many of those algorithms are backed by machine learning. So even if you do something as innocuous as a Google search, the Google search algorithm or the Baidu algorithm or whichever search engine you use has been using machine learning over past instances of people doing that search and your own search history in order to deliver you the best search results, okay? So how they define the best is, of course, a trade secret because they can't let that information go free, but it also means that they're free to manipulate that in any way that they choose, probably not with much oversight from you because you've signed an end user legal agreement saying that they can use your data and that whatever experiment they execute to you may be surprising, may be disconcerting, but they have the right to do that. Okay, so here in this case, Facebook apologized for this, but it's very clear that they have not followed the correct directives. For example, in academic settings, when a psychology department or even a computer science department experiments algorithmically on humans' preference and tastes, they need to disclose this through what we call an institutional review board that lets the subjects as well as the university vet the procedure to make sure it's ethically safe and that users are given due consent. And so platform leverages has its important ramifications, right? So now we have recommendation systems, which we covered in brief a little bit, but these recommendation systems are to try to optimize some reward function, right? That reward function for a lot of platforms is to make sure that you stay on that platform working with Google or working with Facebook or Instagram or whatever the current social media is, okay? They want you to stay on that platform so they can give you advertising. And to do that, they have to offer you things that they think you will continue to enjoy. And those things can cause this echo chamber effect where you're offered more things that narrow your scope of your mind, right? That are already congruent to what you understand and what you believe, and don't expose you to things that are counter to your opinion, okay? But now, because the internet is such a vast place, there are content creators making all sorts of claims such that they will get their content watched. So for any type of medical supplement that you can find that's marketed out there, you can find cases and videos and posts and paid articles to all convince you that this is a supplement is a good thing or that it's a terrible thing. It should never have been allowed to go public. So with all of that content being out there and that you can find either way, our platforms that are doing recommendation are likely to keep on recommending things that are congruent with your already your behavior, and therefore get this what we call echo chamber effect, right? And this polarization has come to a boil. We saw this very much for the 2016 US elections, where there was a lot of claims, however substantiated or not, the verdict is still out, whether those types of interventions on Facebook and other platforms caused the US elections to put Donald Trump into office or not. Okay, so this is a definite worry as it affects the real geopolitical borders of the world. Another instance that's very important to understand is that even though we profess as computer scientists and machine learning scientists not to think about ethics and to relegate that to philosophers, there's actually nothing we can do to stop our algorithms from needing some guidance here. So this is called the trolley problem. So you can look this up if you have some time as you're preparing for your test, about when we have autonomous agents operating in the real world, and they have some physical consequences. So here we have a self-driving car. That self-driving car is moving too fast when it realizes that the visibility or things clear up, and that it's going to have to ram into certain things, okay? So for example, it might decide here to go to its left and kill these two people going through the crosswalk, or maybe it continues straight and kills these two people going through the crosswalk where they're actually not supposed to go through. So there are lots of different scenarios of this. So maybe the two people crossing the crosswalk over here, instead of being normal adults, maybe they're children, right? The ones that are here, maybe they're children, maybe they're elderly in a wheelchair, maybe they're crossing the road legally or not legally, etc. All of these types of value judgments need to be placed into an autonomous system, right? A machine learning system, because in actuality, what this agent decides, what action does it take, is going to be predicated on the algorithm. So we have to figure out what we want to do, because either way, there will be an action taken, somebody will get hurt, and it's now our job as a society to implement the policy that makes sense and decides whether the algorithm is at fault, the designer of the algorithm is at fault, or nobody is to be faulted. And as we'll hear about in the video lecture on the WMDs, machine learning has particular biases, right? So for example, when you try to use a machine learning algorithm to predict where the hotspots in crime are, of course it's going to put the hotspots where it has more training data, right? If you look at downtown urban areas in the US where there's a lot of poor places, and a lot of police actually go there and do actually arrest criminals there, it's going to predict that that's where we need more policing. So if you use this system to decide where policing is supposed to take place, then if you actually put this into operation, you'll send more police officers to those actual locations, and not surprisingly, you're going to find out that there are more arrest cases in those urban spots, those poor precincts, and that it creates a vicious cycle, right? Because there's more crime in an area. The machine learning algorithm says you have to assign more police officers there, and more police officers there means that there'll be more chances for arrest. So this vicious cycle will continue occurring.